Good afternoon. So last class, we are stuck. We are not getting, name notes. So, so there are some interruptions to access VM. So that's why we had to do, one configurations many times, or we are, blocked. So that's why, before starting, even after configuring everything, right? So we need to just format the name node once. So that step was missing. And after the log analysis, we find out the reason. And as soon as we format the node, we are getting the clusters, the data nodes, name nodes, everything. So, and that's why, today, so I just installed, like you guys, 2 VMs in my own laptop, virtual manager, and I again configured the SDFS. So it's including 2 nodes. So in both the nodes, data node processes are running, and in the first one, we are running the name node. So I am getting some error, unfortunately, for this, second node. But anyway, so we are getting, response from our SDFS cluster. So when you, successfully configure SDFS cluster, you would be able to, see this, web view. So you just have to give the name node IP address that you have configured for. And for me, it's just 192.168.0.105. And just to verify, I am just checking my IP address. So this is the IP that I am browsing, and 50070 is the default port number for this view. So here, you can see, the overall the SDFS, the configure capacity. This configure capacity is showing now low because one of my VM is turned off, where I configured this one as a data node, so it's not getting that space. And also, if I run all the partitions, so I configured SDFS in this partition, so in a separate partition /home, and if you see, the size is around 9.4 gigabyte. So now if I go back to the screen, it's around that size. So that is the configured capacity. And DFS is getting only 16.77 megabyte, which is 0.18%. And non-DFS, meaning, in the same directory, we created the Hadoop users, and there are some, base operating system file. So that is allocated around 53.95. So for still, for DFS, we can use this. So whatever the uh, file size is remaining in the partition, we can use for our SDFS purpose. And the SDFS size will be limited to that particular partition. So when, we can, if we can join the other data nodes into the cluster, then you will see the configured and all this capacity will be increased. So here, the live nodes, whatever it's saying, it's one, meaning, we configured 2 data nodes and one is dead, and that's why the live nodes is showing 1. So there are other information also, but if we go to the specific data nodes, okay, so now only one data node is participating. So if we place some file in the HDFS, and it will go to only one location, all the 5 blocks. Though the replication factor is configured as 2, so but when the second data node will join, so it will resync the blocks, and it will, comply with the replication factors. So as long as it will track that, and it will still, response to our queries, and it will still write the files, though one data nodes is not participating. So now even I can browse the files from here. So we have some files. These files, I kept it here. So from here, I mean, you can see the block ID information and size, and also you can download from the web browser. And you can see our SDFS block size is 128 megabyte. So whenever we are putting any files which is more than that, so that I mean, it will piece by 128 byte, and it will keep the blocks, I mean, complying to these replication factors. So for this one, you see the replication factor is 0 because this is a directory, and from here we can see that this is a directory. So if we log into the directory, so this is one file, this is one exe that we have, I mean, kept. The size is 16.6 megabyte, and it is still, I mean, lower than the block size. So basically, we'll get only one block. So there are, so if this is multiple block, you will see the drop down, and this block is only available currently in one data node because one of our data nodes is down. So now let's, I mean, do some operation. So if I want to, I mean, browse my SDFS as we are doing from the web, so we can give this command. So in our SDFS root directory, we are having 3 files, right? And out of 3, one is basically a directory. So if you want to see what is in the directory, you can run like this. So we should be getting only one, which is an RoboMongo exe we have kept. And for example, we'd like to create one new file. For example, we are creating add.txt, and we are putting some text over here. This is our second file that we are going to put into our HDFS. Okay. So now if we want to, I mean, keep this add of txt, let's say within the SDFS my dear directory, then we can run Hadoop fs minus put. So as we are in the same directory, we can give direct file name. Otherwise, we need to give the full path, and then we can mention the SDFS directory name. So it will put that add.txt in the mdir directory. Okay. So now we can again check in that directory listing of HDFS. Earlier we saw that we have only one file. Now it should have 2. So now from the HDFS, if we want to read that, so Hadoop fs. So we know how to read a file. We can use cat command, right? If it is txt file. So this is the line that we have written, right? This is our second file that we are going to put into our HDFS. And if you want to, I mean, remove that, so we should give remove command and like this. Okay. So it's giving an information that this is deleted, and we can cross verify that one. So we have only, I mean, one file left in the particular directory. So let's, I mean, see the overall. So if you're, I mean, familiar with Linux, if you see, I mean, except these 2 parameters, right? The ls minus l, cat, rm, and even creating one directory. So all these are very similar with the Linux commands, right? So if you want to create one more directory, let's say download, okay. And if I need to see again, So now we have, I mean, one more uh, folder that we have created. So let's, I mean, put our created txt in download folder. Okay. And if you want to, I mean, edit the existing file, that also, I mean, you can do just, I mean, using the append command. So it's saying, I mean, downloads, it's the wrong directory. Mm. So there is nothing in the download, but we have skipped one download. Let us check one more time. So let's try to, I mean, put that file again. It is saying the file is exist. This time I hope it's okay. Mhm. So there are some abnormality, I mean, we are observing here. So we have created one folder, but it seems it's showing as a file. So it should be a directory like this. It's taking some time. So generally in a healthy system, I mean, if you want to create one directory, it would be sdfs, dfs minus ls, and then mkdir. And under that, you can, I mean, do all the operations. And if you just need to uh, override any file which is not recommended as per, I mean, Hadoop, that you can do like Hadoop fs minus put minus f. Then let's say in the directory you have one file already, then you can put minus f. So if there is already a dot text, that will be updated. Okay. And also, so let's say there are another type of command which is SDFS and DFS, and which can also copy file from local or get file from SDFS and put into the SDFS. So if you want to copy from local file system to SDFS, then copy from local, or either if you want to take from SDFS, it will be local copy, I mean to local. Okay. So there are two statements. So you can either get it or put it. So there are two type of commands. One is HDFS, DFS, another is Hadoop FS. So there are some examples are already in the documentation that we have shared with you. So you can go through and let us, I mean, back to the earlier slide. So this is, I mean, just basic administration of Hadoop. Uh, so just before going there, I mean, I just have updated that we need to format the name node first, and then we need to start. I mean, just the procedure, high level procedure that we have shared. I mean, what are the steps which are mandatory or optional, and which node it should impact. So here I have updated based on our experience that we need to format and then start. So this is updated here, and just coming to, I mean, basic administration part. So you can start and stop your SDFS. So in name node, you will see name node, and the data node process should be visible using ZPS command. So now if I give something abnormal, I think, so let me, the VM is coming. Let me log in again. Let us start. So the ideal things that I would like to say here is, I mean, if you run it, then just check with JPS command. Then you will get in the name node process is running, and in the same node, if you're running data node, you will get, I mean, data node process. So when you start YAM in both data node and name node, so ideally, according to your configuration, the resource manager should come up in which you configure your resource manager. Ideally, it should be name node, and in the data node side, node manager should come up. And this is the job history. So you will see the same process using JPS command. If you run job history, so if we are gonna, I mean, use yarn submitting a map reduce job, either a Spark job or whatever, then the job history will be kept by this job history server if you add it. And if something goes wrong in your experience, you see the Hadoop file system will not be accessible because it's went to safe mode. And if you want to get it out, just Hadoop DFS admin. So you can give this command. And sometimes it happen you have, I mean, 10 data nodes. So 9 data nodes comes up, but only one data node is not coming up. So you the overall SDFS will be accessible from the user side, but yet one data node issue you need to handle. So you can later on, without, I mean, not touching the other SDFS name node data node, you can still troubleshoot, you can log into that data node, and independently you can handle that data node situation, or you can start or stop or commission and decommission that particular node. So as I shown you, I mean, the web URL which is hosted on name node, and if you are having a firewall configuration, you need to make sure these are the ports that should be accessible or allowed from the outside, so that that URL should be accessible, I mean, from where you are accessing, right? So in Hadoop, we configured this port 9000, some other ports for name node and data node communication. So those ports should be enabled if you are under any firewall. So this DFS, this is the, I mean, web-based view. So if you run a Hadoop DFS admin and report, this will give you the similar, I mean, output like a web browser. Definitely the web browser will give you detail about browsing the file system that you will not get in the command, but you can know how many data nodes participated, what are the blocks, what is the configure capacity and extra. And periodically you can run Hadoop balancer, so it will, I mean, adjust the blocks across the cluster, and it's not recommended to run frequently, because then in the network the blocks will be shifted, right? So whenever needed, you can run. And you can also run some basic, I mean, checks, I mean, knowing a specific file block details, you can check by this command. And if you want to check, because our SDFS configure SDFS block size is 128 megabyte, so that is already, I mean, we can see from the browsing the files and this browser, right? So these are the, I mean, commands which we went through in the documentation. So you want to browse, so you can give either of the command, either is dfs minus ls, the root. So if you want to browse a specific directory, you can put specific directory path instead of the root. And if you want to put a file from your local file system to HDFS, these are the commands. So I practice this one. You can do this one as well. Either of the command will work. And getting a file from HDFS. So in some cases, you need to, I mean, get file from HDFS. So it's just copy to local. And if you use this command, then it will just get from this particular location. And if you want to remove same command, this one should be, I mean, small letter. It will not work if you give, I mean, capital letter H, because this is Linux is case sensitive. Overwriting a file in HDFS, yes, we need to put -f, which is, I mean, yet not recommended, but yes, there is an option to overwrite. Append a file, so there is a file you want to add one more line, so just you can run this line to add. It will run to the utext file. So this is the command. I mean, I remember in the last class or back to class, someone was asking to this question. And if you want to view, so this is the command. So this is a basic command list. But if you, I mean, search or go to the hadoop.apache.org, you will get, I mean, full list of commands. So this is the, I mean, most used command whenever you configure and you need to play with the files. So these are the basic things that we really need in applications. So that's, I mean, we are covering basically the old class, the pending portions. So we will, I mean, quickly, I mean, get back to our present class, which is related to, I mean, Apache Spark. Sorry. So today we are going to, I mean, so we, till now we know, I mean, what is big data and and the key components of big data, and we know, I mean, how to configure a distributed file system. So we took, I mean, 2 machines, but it can be a number of machines, and the procedure is same. And now we need to, go into area of distributed computing. So we know how to store a large amount of data in a distributed fashion and in a cost-effective manner. Now we need to extract some information uh, of large amount of data using power of multiple nodes or machines. So that is part of basically distributed computing, and we're gonna explore that one. So we know that MapReduce is giving that functionality, but due to the challenge, how to write the MapReduce code and what language we need to use from that flexibility point of view, we selected Apache Spark to to learn as part of our distributed computing framework. So we are going through all these topics today. So, so today, we are just understanding the Apache Spark's fundamental. Why? What is Apache Spark? And we have Hadoop. Why still Apache Spark is needed, right? And what is the story of Apache Spark and how its architecture is look like, and what are the components are included in the Spark. And there are some concepts that we need to understand before, I mean, even starting anything to, Spark applications. So we need to understand what is RDD, what is DataFrame, and what is Dataset, and what is DAG, and also how a Spark executes whenever we are submitting any codes. So today we'll go through only the theoretical part, but in the next class, if I'm not wrong, we are going to configure the Spark cluster and see how it relates to our theoretical knowledge. So now, what is Apache Spark? As we already know, Apache Spark is a distributed computing framework, but standard definition from spark.apache.org says Apache Spark is an unified analytical engine for large-scale data processing. So in an experiment, what it shows that it is 10 times faster in disk-based operation compared to Hadoop, and the Apache Spark is 100 times faster in terms of in-memory computations compared to Hadoop. So what does it mean? So in Hadoop, the MapReduce is always using the disks to complete its batch processing in a distributed fashion. So here in Spark, we can, define how it should run. So by default, it will run in memory, and it can run both in memory and disks, and you can define even it can run only in disks. So that kind of flexibility Apache Spark is given to us. It's originally developed at the University of California, and later on it has been, donated to Apache Foundation so that, all over the world people can contribute and make it in a mature product. And it is a mature product, and it is being used mostly for real-time analytics. But it can both. It can do both. Batch and real-time. It's not only can support real time, it can also support both batch and real time. So the right side, if you would like to, know more about Apache Spark, you can go to this URL, and the screen that is showing here, which is, this is a logistic regression has been done on a large amount of data set, both in Hadoop and Spark, and you see the result, and the timings is about, 100% better. 100% faster than Hadoop. So now, let's go into a deeper insight. Why we would need actually Apache Spark, where we have Hadoop, and it has two components, which is serving as a distributed computing framework as well as a distributing storage solution. So So as we explained that MapReduce only do batch processing. However, Spark can support both real time and batch processing. So batch processing means, I mean, if there is any confusion to all, even let's say we schedule a job and it will run over a large amount of data and it will give us an output, right? This is a batch processing, we schedule it. And real time, it means, I mean, from an application, users want some data. This request is forwarded to a backend server, and backend server request Spark to run and get feedback, which will be, I mean, forwarded to user in real time. That is basically called real time. So I mean, you may have confusion, so that's why I'm just giving an example. So Spark does both. So you can run your schedule job, you can run a real-time query that has been requested from a web portal, and you want to get back the result to the user. I mean, maybe within few milliseconds. And Spark is much faster than Hadoop. I mean, that is being claimed because it supports in-memory operations. Spark gives much more, I mean, support for programming. So in Hadoop, so it is built on Java, and you should write, I mean, map reduce functions, map and reduce on Java. But in Spark, it is based on Scala, and the Scala is running on underlining JVM, but you can code on Scala, Python, Java, and R. So you have a lot of options, I mean, for programmers to choose. And in Hadoop MapReduce jobs, as I said, it's only support Java. And in Spark, there is one interesting thing that we can do interactive, I mean, programming using Scala, Python, and R, and SQL shell. So interactive mode is not supported for Java. So for our, I mean, practical session, so we choose to use Python. So we can use a backend mode or an interactive mode. I mean, to submit or work with Spark. And it runs everywhere. It means it can run in any physical machines or virtual machines or in cloud or containers, and it can run on any platforms, and it can integrate or take inputs from various types of data sources. It can be from Oracle database, from Sybase, from a file, from a CSV, from a HDFS source, from HBase, Cassandra. So it supports a variety of platform. I mean, to input and even output data after processing. And coming to the most, I mean, fundamental reason that why I also personally use Apache Spark as a distributed computing framework, because it's easy to write. So we'll use, I mean, basic MapReduce functions, and we'll use the SQL-like functions in Spark SQL. So you'll see, I mean, how much easy in Apache Spark using Spark SQL. Just write the SQL. That SQL will be converted to, I mean, MapReduce job internally that we don't need to bother about. And it also has powerful caching facilities. So if we define, I mean, some objects, then we can define the persistent of the object. If we define is a cache, then Apache Spark within its life cycle, it will, in the execution cycle, it will keep as cache so that, I mean, the performance can be improved. So you can see, I mean, a simple code base where we are creating one data frame. So the first, this is, I mean, we are just loading the libraries, and the second line SQL context. So this is SC as an object. It says, I mean, this is a Spark. So to log in a Spark, so SQL, I mean, the Spark context object is the base and it's the gateway. I mean, whatever we use in a database connection, that is, I mean, it's very important. So we pass that SC Spark context object to SQL context, and we get a SQL context object. Using that object, I mean, we can read one CSV file and wrote in a data frame. So data frame is in-memory objects, and we can do many operations like that. So we'll see. This is just an example. I mean, how we can take data in a data frame using Apache Spark. So coming to the Spark architecture point of view, I mean, how it works. It works, I mean, in a similar model what we discussed earlier also for, distributed computing framework in Hadoop. MapReduce. So from the application that we'll be writing, that will submit the request to a driver program, and that driver program has to initiate one Spark contest object. So this is a gateway to get access of the resources of Spark, and based on the request from the application, the driver will talk to cluster manager, and cluster manager will book the resources, and then the application code, which we generally called as a job, that job uh, will be analyzed and broken down in stage and tasks, and those tasks should be distributed to the worker node. And in the worker node, basically logically the executors are running. So in the executors, so the tasks will be assigned, and executors will be giving back the tasks outputs to the driver program, and it will accumulate, and then the final output will be given to the applications. So this is the way, in high level it works. So now when we configure how it will work, so we'll configure one master node and couple of worker nodes. So like name node and data node, in the same host, we can still provision master node and worker nodes. It will work. So you just need to ensure that you have proper resources in the host where you are putting driver and executor. When I say resources, it's always, it's always resource means CPU and memory. And whenever coming to the cluster manager, so in Spark, we can submit, we'll see details. We can submit job in multiple ways. And these cluster managers can be different based on how we want to run the job. So we'll see that. So now for the time being, so see the driver's responsibility in a more formal way. The application, hosted in driver. So we'll be requesting or placing our application to the driver, and driver basically owns the code, and it creates a JVM for the code. The overall process, will run on top of a JVM. So whatever you are coding on Scala, Python, is finally it's running over a JVM. And Spark context, so this is a gateway. It's like a database connection string. So using this Spark context object, you are getting actually the access of a Spark whole cluster, and then you can perform whatever actions you need to do. And cluster manager is always is the big boss who can allocate resources for you, so that you can run your jobs and tasks and stage whatever. And also it can schedule the Spark applications. In the worker node, so they are the slave nodes, and whenever you are initiating one applications, that means at that time in the master there will be one driver. So this is on the fly, and in the worker node you will find executors, and they will be executing your tasks given by the driver. So as soon as the Spark application is finished, right, then your driver and executor processes are died, right? So there is, so these driver and executor concepts are whenever the application is running, at that time you will get one driver, multiple executors. Otherwise you will say this is a master, this is worker. So now coming to Spark components. What are the components? So slowly we'll be understanding how it works. So So Apache Spark, this is basically Apache Spark core, and we have Spark SQL, and then we have Spark streaming, we have machine learning libraries, and we have libraries to handle graph data as well. So what is Spark SQL? So Spark is giving one SQL-like interfaces so that we can query using our standard SQL schema over different type of data sources utilizing Spark basic object model, which is RDD, DataFrame, and Dataset. We'll see what is RDD and what is DataFrame and Dataset in later slides. It allows developer also to connect to a data stream and on the fly process those streaming data in a large cluster. So Spark streaming is to handle the input stream as well as continuously generating output using the cluster mechanism. And Spark, the mlibs, it supports running machine learning algorithms like clustering, feature extraction, correlations, etc., over large dataset using Apache Spark mlib libraries. And also it can handle both graph data as well as non-graph data and do multiple type of data transformation using the library. And the Spark core, this is the heart of the Spark, which is actually responsible for all the IO function, scheduling, monitoring, and its work as a base engine for all these components. So this seems, I mean, theoretical to you, but let's say we'll deep dive with the Spark SQL mostly in our practical session also. And of course, we'll know about RDD and DataFrame also in our practical class. But if you are interested, you can, I mean, work on Spark streaming, MDiv graphics in the same model, the same way we use. So let us understand, I mean, what is Spark RDD, dataset, DataFrame, and DAG. So RDD is called as resilient distributed dataset. So for example, so here you see, let's say this is an object, we are creating a Spark. So as C is the Spark context object, and dot parallelize, and we are getting some data, right? Random data into the number. Okay, so this data is very small, right? But this data can be, I mean, very large file. We can import in a certain object, and these objects will create one RDD, and that RDD is a distributed data set that can exist across multiple nodes. And we can do, you see, we can do some operations. So we are finding log of this each number, and then we are collecting the output. So we can do multiple operations, and these operations will be done across different workers or executors. So RDD logically is a collection of items which is distributed across multiple nodes, and on top of those data set we can do multiple operations. So RDD is a basic block of Spark. So RDD can be cached and persisted. So we can define whether an RDD should be cached or not. Otherwise, an RDD will be died after some interval. It's not being used. It will detect automatically, and this memory will be freed up. And this RDD is resilient, right? So its name is resilient distributed datasets. So that means that RDD can be reconstructed in case of any failure. And it follows DAG. So that DAG we will, I mean, see in a practical example, maybe when we do the practical session, how it will draw one acyclic graph. I mean, and from that graph, it can also reconstruct the lost RDD, as well as before assigning a job to the executor using that, it will, it will make one physical execution plan and break it down to multiple stages. From this stage, it will break down the tasks, and then it will go for the executions. So we'll see such examples in the practical sessions. And RDD can be partitions in multiple cluster node. That is understandable because anyway, the RDD will be distributed over multiple executors, and it is type safe. So what it does, so in whenever we are loading these, let's say, numbers, so there is no typing has been done. Either it's a number or character. So it will try to do some kind of operation. If you load characters also, it will try to convert your character to some numbers, and it will try to give you some value rather giving any error. So this is type safe, and it's lazy. What does it mean? So in Spark, uh, generally what we are doing for this example, just to make you understand why it's lazy, that we are loading these numbers into an object. Let's say this is an array of object for the time being, and we are, making one map function so that we can find the lambda value of these numbers, right? So, and we are storing in another RDD names log values. But but when we run this one, right? Either we are running in a batch mode or backend mode or in an interactive shell. So this part is not doing anything. So that's why it's lazy. Until unless you are asking some output from Spark, Spark will not initiate anything. It will take your input, and as soon as you ask some output, so let's say the log values dot collect, the collect is asking to give some output. Give me the log value of these numbers. That's what you are asking. Log values dot collect. So either you are collecting or you are counting, or maybe you can say give me the first two value or one value, whatever you are mentioning. So when you are asking an output or you are trying to save output in a particular file, only that moment Spark started seeing all of your commands, and it will try to optimize the way it should run, and then it will give you the results. So whatever transformation we are doing on top of one RDD or one distributed data set, it's not being executed or perform any action until you ask for an output operation. So that's why it's called lazy. And then coming to immutable. So it means whenever you created one RDD, you cannot change it during the execution period. That sounds, we are not familiar this kind of things, right? But yeah, RDD works like that. So as long as you are in execution mode, you create one RDD. If you need any transformation that you would like to do on top of an existing RDD, you have to save it, into a new RDD. That's what it's designed and it's recommended. So that is called immutable. And now, in experience, what it's shown that for all the non-JVM platforms or languages, it becomes slower, a bit slower than, uh, let's say it's efficient as is written in Scala, it's efficient in Scala, but if you run with Python, the processing will a bit slow. But difference is very, it may not be comparable, but you will get better performance if you use Java or Scala. And one of the challenging things, in RDD, that so we do, in our business purpose, we do various transformation on data, and then we need the outputs, right? And the way this transformation has been done, in general, it's likely that because of our knowledge or stress, whatever reason, we may, write a wrong statement using RDD, and it may cost us a lot of times. So the optimizations is not inbuilt with RDD operations. So let's check this example. So what we are doing, let's say for a Uber trip application. So we are, trying to see or join two sets of data. One is trip and one is user. And based on the trip user ID as well as the user ID, we want to do some kind of operations. But we want to see the data which is more than 1st April, right? So what we are doing, we are joining the two data set first, right? And we are filtering using the trip date in the trip table. What's wrong if in these operations? So generally, in our small database, if we do this kind of operation, it does not matter basically. But if this user table and trip tables is storing, let's say petabytes or terabytes of data, it does matter. But if we change the the flow of the query, right? So let's say we first separated this filter one before comparing with the user table. So we filter the trips table first and then try to join with the users. Then the operation will be efficient and there will be no change in the output. So if we give this command to RDD, so RDD will not be able to identify inefficiency within the query, and it will run and it will take longer time. Okay, so this is the this is very common that we can write an inefficient query which a system should be able to identify, and that's intelligence is not within the RDD base transaction transformation and actions. So if I have to want to see this, when we create the RDD, then it will be a distributed data set that is exists in a partitioned way in multiple worker nodes, and we can do some kind of transformations. So if we do some kind of transformation, we need to create one more RDD, and if we want to do some actions, we want to do some output, take some output, and then we need to ask the system, and then the overall process will start basically. Before that, so it's just tracking, it's not doing anything, that's why it's lazy. And then we can see the actual result either in our screen or in a file, or it can give output to a persistent storage as well. Going to HBase or MongoDB or Oracle, it can write back as well from the Spark execution. Because Spark, when it start and when it end, after end there is nothing. Okay, so if you need to save your process result or output, you have to write the output either in the terminal or in a file, or you can write the codes so that it connect to external database and save the result and then terminate its process. Now, what is DataFrame? Okay, so DataFrame is an enhanced versions of RDD. So DataFrames provide, higher level abstraction, allowing to use SQL queries over the dataset. And it can be created also from the RDD, and it can also be created from different Spark supported data source. If you see the right side examples, so from a text file, we are creating one data frame. So before creating data frame, we need to create or initiate one SQL context. and from there we are reading, I mean, one txt file. So this txt file is basically a CSV file, I mean, internally as a payload data format. So that's why we are using one Databricks API, I mean, to convert and load it as a data frame. But in the data frame, the difference is has type. It has type basically. So you need to define the schema of data frame. It's like, I mean, and structured data where there is, I mean, a column or row format data, and it specific type. So if you are, I mean, let's say string, and you are trying to get some different data type, then you might get error. So this is one, and still also this is a lazy evaluation. So this is, but it can be mutable. So in the data frame, so you can overwrite the output, and data frame queries are optimized. So what we see, this example for RDD, if we do this kind of operation in using RDD, so there is no optimization automatically from the system. But if you do it for data frame, the same operation, the data frame optimizer, what will do, it will, I mean, perform the filtering operation on the trips before, I mean, joining with the users table. So that will be automatically done by the system. So that intelligence is brought into the data frame. So that's why data frame queries are optimized. And internally, the data frames on top of, on that data, we can always, I mean, initiate the SQL queries. But finally, when it will run to the cluster, it should get converted to RDD, because we know that RDD is the basic building block for Spark. So on application programming or interactive shell, whatever we are using, either we use data frames or dataset or any other things, that will be converted finally to RDD. But the data frames APIs will give us, I mean, the basic and unoptimized query also. It will automatically detect and optimize. But that optimization is depends whatever, I mean, features and capabilities is stored in the optimization engine, and it's being developed day by day, right? So we should not expect that whatever, I mean, next query will write, system will automatically, I mean, optimize. No, has some limitation, and it's being developed day by the, I mean, group of people in the world. So we have RDD, which is immutable, which has some, I mean, drawbacks of not having optimization in build. Now we bring data frame, and in data frame we can write. This is a great advantage. So any people who are using or working on normal application development, knowing standard Python, Java, and SQL syntax, they can use, I mean, in the Apache Spark, because, I mean, whenever you just initialize the Spark context object and getting the SQL context, then you are, I mean, free to run the SQLs and getting back different data frames. So it's very easy. So data frames is coming with different, I mean, uh, advantages. But the disadvantage is data frames is a schema based things, and it's a type thing. So if you are, I mean, doing some wrong typing, so your whole operation might be, I mean, uh, error prone, just to writing a mistyping of a particular column. So that's happened in our regular programming as well. So this is one issue. So now what, I mean, the forums are thinking that how we can more optimize the data frames, as well as, I mean, how we can be type free in a sense, and and still we, I mean, uh, can we get the benefits of RDD as well as data frames in one single frame, that is datasets? But it's still being developed, and it is called an extension of DataFrame API, and we can still run SQLs on datasets, but and it's conceptually like RDD, and it's certain level of type safety is there, but it's not fully, I mean, type free. It's lazy, yes, because it's a common Spark feature. Until unless you are not asking any output, it will not do anything. So it's kind of lazy, and it's mutable, so you can still override. And queries are optimized, so that is a huge improvement in dataset. So, and it used a special kind of, I mean, in-memory encoding schema. For that, we would get tremendous, I mean, performance improvement over data frame and RDD for serialization and deserializations. So, I mean, just to understand what is serialization and deserializations. So we remembered, we gonna have an example of MapReduce word count, right? And there, I mean, we read two files, and then we perform the map. I mean, we need to separate each file, each line, and out of this line, we identify what are the keywords, and we count 111. And then the same kind of word we have to, I mean, keep in the same place so that it can be reduced or aggregated. So whenever this kind of reduce by key or aggregation is required, because we are doing operation across multiple cluster nodes, so there will be shuffles required, so that the same type of words are processed in the same node, and it can be reduced or aggregated. So these kind of things, when data has to be transferred through multiple cluster node, so we need to use serialization and deserializations. So generally, Spark use Java deserialization method, but in dataset, it's using a special kind of serialization and deserialization technique that is much more faster than the Java and Cairo serialization deserialization techniques that is being used for data frames and normal RDD. So, I mean, as Spark is based on RDD, so whatever we are using data sets or data frame, it's finally is converted to the immutable RDD. So if you see these examples, I mean, sc.text file. So from the SDFS, we are, I mean, loading one ebook. In the ebook.txt, a lot of ebooks names are there, and it has been loaded in lines RDD. So this is creating one RDD, and here we are trying to identify the words in the next statement, and then the counts using the group by statement. So these are, I mean, syntax from Scala language, but this is from Python, the first one, but we'll be using the Python for our practical exercise. So we'll use both data frame as well as RTT to perform different actions and transformations. So here in the dataset, what it's doing, so you see that whenever we are loading this ebook.txt, we are saying as a string. Okay, so we are loading as a string, but whenever we are defining the datasets, all the operations which will be running in Spark will be using the efficient methodology of serialization and deserialization, so that the performance will be better, and we'll get some type of, I mean, type safety here, because it's not that, I mean, the every column and every column properties are tagged with a free, I mean, uh, fixed type of type, but still, I mean, as we load as a string, and in some of our code, if you are expecting some long or floating value, then it will still give you error. So the type issue is not able to fixed even in datasets. So that's why it's being still improved. But there is significant improvement in serialization and deserialization algorithms, so that it gives much better results than DataFrame. So all, I mean, operations that we'll do in Spark, that will either loading data into RDD or dataset or DataFrame from various sources. So if we remove this SDFS colon, then it's a path in our Linux or Windows box, right? So it will take data from SDFS. It can take from local file systems, either can be Windows, Mac, or Linux, and it can load directly even from MongoDB or any other source. And it can, so these are the, I mean, transformation, I mean, flat map, group by. So these are all transformation until unless, let's say, we are not doing any action. What is action? This dot count in the dataset example, this is an actions. So we are asking system to count for us. We are asking system to, let's say, collect data from us. We are asking system to save data in my file, or we are asking system to write data into external database. And that time, the execution will start. And until then, Apache Spark, the driver programs is taking all the inputs and has not been created or executed anything. But whenever we are loading the data, that data is distributed and persisted in memory. But if we define the RDD can be in a disk, it will start writing the RDD information in the disk as well. But by default, it's in memory. And it can be configurable, whether we are trying to run its in memory or in disk. It depends on what's the data volume that we are trying to solve and what is the memory we are having in worker nodes or driver nodes, that we need to see and define. Either we have sufficient memory in memory to support the in-memory operations, or we need to take help from the disk. So it's based on data size and the problem that we are trying to solve. So, I mean, this is the model, the way Spark works. So let's try to, I mean, give an example that how it works, right? So for example, one user is submitting this course, right? This is a because it has, I mean, transformation, that it's loading one string, doing some mapping group by statement and taking count. So whenever there is a count, that means it will extract uh, the actual operations, right? So driver program, when we assign, it will assign to a driver, and we need to mention who is the driver, what is the host, uh, who is, I mean, acting as a driver. We need to mention that host IP or details. And there we need to mention how we are submitting the jobs. So jobs can be either local, I mean, one single host which is hosting worker and the master, means whenever it is running, it will create one driver and executor in the same host. So that is local, which is used for development. And standalone cluster. So using Spark submit command, we can submit our Spark job into a cluster. And we can use also yarn, which we have configured in the last class. So using yarn also, we can, I mean, submit Spark jobs. So that's what, I mean, the yarn is giving us this flexibility, which MapReduce cannot give. So if we are only on the MapReduce, which is part of a big component of Hadoop, so using that MapReduce, we cannot submit our Spark job on the Hadoop cluster directly. But using Yarn, we can submit our Spark job on or to run in that Hadoop cluster. But yes, that Hadoop cluster may have name node and data node, and we need to make sure that Spark is already configured with worker node as well as master node, so that it can identify the executor and driver in a runtime environment. But Yarn will be managing as a cluster manager. So driver will be requesting to Yarn, please give me the resources, and that resources also can be defined in the Spark context object initializations. What memory you are assigning for executor, what memory you are assigning for driver program, that you can maintain based on your data volume that you are going to handle. And then the Apache Mesos, this is also some kind of, a cluster manager. So in this way, we can submit the job. So whenever we are submitting either of the process to a driver program, and we can submit in 3 ways. So either it can be batch, we schedule the job in a particular time, the job will start and running in the background. Another is interactive mode. We run, let's say, a shell environment like the way we give command to the SDFS. We give different commands and it is giving us output. It gives what are the files in the SDFS, it is showing this file, that directory. If you go to that directory, it is showing all the files and folders within that directory. And if we are asking for removal, so this is the way we can interact with the Spark shell, and we can run transformations, and we can run actions as well in Spark, which is called interactive. And Spark supports 4 languages, which is Java, Scala, Python, and R. So R is a statistical, language. It's been used in largely in the machine learning and statistical analysis. So, all the languages that support this interactive mode except Java. So as we are using Python in our practical exercise session, so you will see, we'll do both, batch and interactive. And then additionally, it can connect, to a data source, which is, pushing data as a stream, and it can process that one, and then giving an output as a stream or any other format. So, the way how we can submit, it's the how the cluster manager is can work. It can be local, standalone, Yarn, Apache Mesos. In this way, we can select our cluster manager to run an execution. And how we can run, it can be scheduled or interactive or streaming. So let's say we submitted one job in a driver program, and definitely is a user code. So that code is submitted, and in the driver program, whenever we are submitting, we are specifying in the user code or either in the driver submission in the job, we are maintaining or giving the resources. If you are not giving the resources, it will read the Spark basic configuration, and it will see how much memory or CPU that needs to be allocated for that particular job that we are talking about. So then it will identify, it will analyze the user's codes and all. And so whenever it is running in batch mode, that means the user is already specified both transformation and action within the program, because user is not interested to do only the transformation. User definitely wants some output. So that output, either it can be count or collect or putting output in a file or writing in external database. That statement is there. So as soon as it is getting everything, and using the DAG, it will identify the different stages, and within the different stages, it will identify the unique tasks that has to be assigned to the different worker nodes where executors are running. And then when the executor finishes the task, so it will go back to the driver nodes, and it will accumulate, and if required, it will do some shuffles over the network, and then the final output will be given to the users. So basically, applications is some kind of logically a job, and based on the DAG analysis, so it would be divided into multiple stage, and the multiple stages will get multiple tasks, unit tasks, which will be assigned to executors. So as like the map reduce, these tasks, I mean, uh, these are fault tolerant because these tasks, whenever it is assigned to executor, the driver program is overseeing all the operations and the timeout periods, so that if there is something, I mean, wrong with the executor or it's taking a lot of time, then drivers can reinitiate the tasks. And the data that had been assigned, I mean, or loaded to Spark in memory, that 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 is already distributed in multiple executors. So that if that level of data can be, I mean, also, I mean, faulty because of executor is down in the middle of executions. So as I said, the RDB is fault tolerance, and that's why it's resilient, because based on the DAG information, it can reconstruct the lost data of RDB and then put back to the application's code again across the cluster. So, I mean, this is the way, I mean, the Spark executes user codes in the cluster. So there are multiple techniques to run that, and basically, whenever we work on distributed computing framework, so it's really, I mean, mandatory to understand how it works. So whenever execution is running, so like SDFS web UI, so for Spark also it will give you a UI view. As long as the job is running, you can see that screen, and in that screen you will find job, and you will find stage. If you click that stage tab, you will get task details, and who is the executor running the task, how much time it is taken, and how much data it is being handled, and how much shuffle operation it is required to do, and how the DAG visualization is being done. So all these details, I mean, will be shown in a view, in a web view, and it's only persistent as long as the execution is not, I mean, is valid. So as soon as the execution is, I mean, over, the URL is not, I mean, accessible, but you can still, I mean, get the details log of the uh, application running details if you want to keep. And let's say we run this Spark job using yarn, and we are running that job history server that we started earlier in our example. So the job history will keep all this information. I mean, when the job is assigned, how it is broken down to tasks, and which executor is running what tasks, and how much time it takes in overall. So uh, it will keep track all the history. And if there is any errors, then you can see on the from the logs, I mean, what went wrong. So in the most common scenario is out of memory error. So this is very common error. So because whenever we are loading the RDDs, so we need to understand how much data we are loading and what is our executor memory. And we can, in our practical session, we can see, I mean, we can do multiple, I mean, partitioning of RDD, so that the multiple partition RDD can be distributed in multiple executor, and multiple executors can run in parallel with their own resources to finish the job. So if we are not partitioning enough, and one RDD looks very heavy, and it's trying to load into the one worker or one executor memory. Sometimes it comes with an execution error, like out of memory error. So if you are in distributed computing programming, if your programming, let's say, is there is no error logically, and it's go to go, but still based on your analysis and of the resources, still it might have some problem. Either maybe the job is finished, but the job is finished with an unexpected time. I mean, you are not still reaching that expected I mean timing or latency that we are expecting, because you have not do the partition of the RDD in a right model based on your executor or executor resources, or based on your data set that you have loaded already. So that is a part which is, I mean, whenever you understand the basic principle, try to run some codes, then you gradually need to understand how to optimize. So there's a second level things. And one important thing is, let's say you are running one program, and your driver is having one CPU core, your executors are having one cores, right? For example, you have two executors here and one driver program, and you assigned one job, and you asked to run two executors, and also one driver definitely is required, and you block all the CPUs of executors as well as driver. When the jobs is running, if you want to run another job, which will be requiring, let's say, one executor, one driver, then you will see a message saying that resource allocation is pending. Because as long as the Spark job is running and you assign a fixed amount of resources to that job, so it will block that resources. If it is memory, if it is CPU, it will block that resource portion until it's finished. So that is also a point that you can, I mean, take a note, because, for example, in a Python we made five, I mean, parsers, right? And when we submit or we are running those parsers in parallel, so it is trying to, I mean, share the CPU cycles, right? But in Spark, if you define CPU cores and memory for worker and driver, so it will block that resources for that particular runtime. So in parallel, whatever you want to run, you need to count that resources. Otherwise, your second job will be pending, I mean, will be shown as a resource pending. So you will get notice, and it will automatically start again whenever the primary job or first task is finished. The resource will be freed up and it will pick automatically that resources. And even you can see from the Spark that web view, because this job is running but it's waiting for resource. You can see from the web view, where you will see, I mean, job, stage, DAG view, driver, executor view. In that view, you will see that it's waiting for the resource. So that is the, I mean, way, I mean, the Sparks work in a real world. And whenever we'll see, I mean, Spark working modality in both batch mode as well as in interactive mode, and there we'll open the web view and see how, I mean, our jobs are being divided into stages and also in multiple tasks, and which executors are executing and how it is being executed. And also we can take some examples of RDDs, and we can take some examples from DataFrame, and see in the DataFrame how, if we write a wrong query also, the Spark can detect and optimize in certain level, so that it gives us output, I mean, in efficient way. How to solve namespace ID incompatibility. Okay. So I mean, I need to, I mean, get some screenshot of logs. So we are trying to create one blogs or forum kind of things. So we'll let you know. there, I mean, you may have one account, and then we can discuss over there, because there might be many problems from many sides. So even some problem can be, I mean, solved by participants. So this kind of issues, I mean, if we discuss in a forum, so that will be easier for us to help each other and solve. I am facing problem install a JDK or another file in J. Cannot access disk drive hard to. Okay. I mean, you cannot download the JDK. So we shared in Google Drive. So we are having some problem in our cloud VM. So that's why it's been shared in Google Drive, as well as I think in our web URL, right? Ibrahim? So you should be able to download. Instruction, it was to CentOS host, Windows client for name node. Yeah, so you can use Windows, I mean, for HDFS, but I mean, the instruction will be given always for CentOS. So, I mean, if you do in Windows, so you just need to take the method of procedure from, I mean, Google or somewhere, but I would recommend to install CentOS. And so you want to install Hadoop latest version in lab environment. I won't recommend, but I mean, after finishing the course, I mean, start exploring the other stuff. So latest version is always appreciated, but the way we'll, I mean, do our exercise, so that will be with, I mean, the Hadoop 2.7.1. In Hadoop configuration, for example, in core side, we'll use IP address or host name. Okay, so it is the cluster in your machine, right? So if you give IP address or host name, if you give host name, you need to make sure that your host name is, I mean, it is available in the etc hosts. Okay, as long as you are having entry in the etc host file, so you can put host name in the, I mean, core side XML or whatever configuration you are doing. That is absolutely fine, and you can do a ping with the host name, so that you are confirmed that that host name resolution is, I mean, is happened. Can I directly go to HDFS shell? Yes, you can. You can go after installing. You can go to directly to HDFS shell and do the operation. But if you are not running with any HDFS, or you are having issue with your name node most probably, then your HDFS shell definitely would not work. I created 2 nodes according to PDF file, but 2 nodes are working. But when I run it in the browser, okay, it shows 1 live nodes and 1 listed data nodes in the browser. Is it supposed to be 2 live nodes? Yes. So if you configure 2 data nodes, definitely it will show 2 live nodes. So in the data node tab, you can go and check that which data node is not coming. In that data node, I mean, you can run Hadoop space data node. Then it will start giving, I mean, the details why it is not running in that particular instance. So the command is Hadoop space data node. You just enter and then it will work. What is the function of the following command given the last? Okay. So this is, I mean, let's say in a Hadoop fs minus put. So what is the function? So let's say in our HDFS, we are having one directory parse dev. So in the parse dev, we'd like to keep files in our current directory, which is having ho underscore this date time, right? So let's say we have 100 files which is complying with this date time within their file name. So what this statement will do, it will take all the 100 files and put into this place within this single command. So this star will work as a regular expression. I mean, you know the regular expression. So the regular expression will match with all the file names existing in the current directory from where you are running. Then it will put all the files into the parse tab. Hadoop balancer used to shift or change master node. Hadoop balancer won't shift or change your master node because Hadoop balancer work is to, balance the file blocks, user file blocks across data nodes. So it will not, change your name nodes. Which topics do you evaluate in the test? Okay, so in the test, it will be, mixture of the theories that we have completed up to last class. I'm talking about the upcoming, and plus there will be some common syntax that is asked. If you go through the materials and do some, analysis, then you should be able to answer. It should be very easy. One driver per worker node. One driver per no. In the driver program will run within the master. So you can consider it's a name node type of things, right? Who is controlling the cluster? So driver is controlling the cluster. And uh, then in the worker, so you may execute the executor. But you are right, within a host, we can run both driver and worker program. That is possible for, just for our development. Spark streaming, that is, we can give an example, maybe in the practical, but it's not part of our course. So we'll do, Spark Sql, and we'll use various techniques to, submit a Spark applications. So we'll use Spark SQL libraries to perform our, practical classes. Is there any size of RDT, or it is reconfigurable? So sizing of the RDT is depends on what you are loading. So it's configurable means it's kind of configurable. What data you are loading is depends on that. Queries are optimized. Please explain it. Yeah. So I explained one example, right? As I said that queries are optimized. So this one, right? So if you understand, we have a table of users. We are having user details, and there is one table called trips. Let's see what trips. There we have user ID and the trip details from where to and from information and details, right? So if you want to get some data, of after April 1st, right? So maybe you are running the business since last 7 years, right? And you are having all the data online. Then, so what we are doing here? So let's say I did some wrong. I am joining first user table and trip table, and then I am putting filter to get the trip information, which is after 1st April. So this one, if we use as a data frame, then the data frame optimizer will detect this inefficiency. Then it will first filter the trips, which is after April 1st, and then it will, join with user ID. So that kind of, optimization is possible, in data frame. Hope it's clear to you. So even we can, see practical examples when we do exercise in next couple of class. Our executors will be running on our data nodes. Yes, it's possible. So data nodes is a process. So don't be confused. Data nodes is a process which is running in a host operating system. So in the host operating system, you can install your applications. So Spark is a distributed computing application. So you can install, Spark worker and master nodes also in the same HDFS environment, because your Spark, will not be running continuously, right? So whenever you are assigning job, only that time it will take the resources, and whenever it is done, so it is not at all taking your resources. It is just silent, right? So, but in the HDFS case, it is continuously running because users needs to have the access continuously. But for Spark, as long as the execution is over, the resources are free. But yes, if we are considering two configure Spark worker and master node within our HDFS cluster where name nodes and data nodes are there. As we see the resource planning, I mean CPU, memory, and network bandwidth and all for HDFS, we need to consider the amount of, I mean, RAM and CPU that is required for a Spark. And even when we are configured with that, even while running the Spark job, we need to assign the CPU core as well as memory carefully by keeping the CPU memory for the data nodes as well as name nodes. Otherwise, the Spark will, I mean, block all the CPU memory and it will create, I mean, problem for your data nodes and name nodes to perform, I mean, without any error, right? So can you explain parallel processing? Yes, it's parallel processing because whenever you are loading the RDD, it's been partitioned and distributed across uh, the data being distributed across the, I mean, executors. And then when you assign the job will be divided into, I mean, multiple stage, and multiple stage will be divided into tasks. So, and those unique tasks will be, I mean, given to the executors. So as we are loading, I mean, RDD, let's say for numbers, these numbers can be, I mean, very big here. So I showed here numbers 4, 2, or something. This can be, I mean, 1 gigabyte or terabytes of number data. So whenever we are loading RDD, that is this data is loaded across the cluster. So whenever you are running the data, some data will be on the executors. So when you pass that code to do some kind of operation, so it will locally access those RDD partitions and do the, let's say, the lambda functions, and return back the result to the driver so that it can accumulate and put back the result to the output, I mean actions, either collect or saving in a file or saving in external storage. Please tell me again about datasets. So datasets is something, I mean, that is still being, I mean, worked out. I mean, we would like to uh, keep the RDD as well as DataFrame and Runbase into one place. So one of the fundamental advancement in data set is that if we need to do reduce by key or aggregate, that means we need to shuffle data across network to send same type of data in the same node. So we need to shuffle data across network, and there we need serialization and deserialization. So there is one enhanced mechanism is being followed in dataset, so that the efficiency is, I mean, is very noticeable against, I mean, operation over data frame and base RDD. But still, I mean, there is one more option is if you run a big program and in that last stage for the type error, your whole operation is, I mean, aborted, right? So this type is not, I mean, fully resolved. So if you are expecting some string but your data type is internally flawed, then again it will give fault. Still data set, this problem still remains. But from the execution point of view, it will give you, I mean, a lot of efficiency in terms of any operation which requires, I mean, shuffle operations. Or when we submit Spark job, is there any way we need to say to execute it multiple or it logs it? Okay. So yes, we can define. I mean, we can define all this, but in a Spark there is one configuration. So if you just define the driver nodes, or if you don't decide, so it will automatically take from the configuration. But if you define that, your definition will be, I mean, taken. Otherwise, it will go and see what is in the configuration and it will work like that. What will be the mark distribution of this course? Okay, that will be mentioned in the, I mean, that will be mentioned in the each, I mean, exam, I think. So I have successfully installed HDFS in single node. However, for multiple nodes, I'm not able to assign IP address to the virtual machine. I am using 3 VMs in VMware. Is there any document on assigning IP and interconnecting different VMs? Okay, so I don't know how we are using, but if you are using Oracle VM or any other VM box, and you create one machine, so by default, if you, follow my steps to install CentOS, there you can enable, the networking portion and give the host name, and it will initially uh, assign you one private IP. And if you give IP address show command, it will show you command, and that will be by default in a native mode. So if you want to get access, internet access, you can configure the network to the breeze mode. I mean, uh, let me show you that. So this is one VM, and if I go to my network portion, so if you see by default when I install my VM, this is Oracle VM box, so it will be NAT. So when it's NAT and I start my VM, it will get some private IPs automatically, and I can get it that private IP using, IP address. Show command, right? There is some command if you see in the Linux documentation. So you can see the IP from here, but what I have done that just do the breeze network so that I mean this host will take IP from my Wi-Fi router or from my DHCP automatically, and it will be connected with the internet if I have internet in that router. So so you can follow these kind of things, and that will be easier for you to install anything if it's connected with the internet, but it's not mandatory to do that. I download all of them, but my question was to install JDK or other download files from disk drive. I cannot access them from VM. I don't know, but my question was to install JDK or other downloaded files from my disk drive. I cannot access them from VM. Yes, but you can use so as I shown you, right? So you just change from NAT to Breeze. So you will get one IP from your DHCP if it is supported, and then from your local Windows machine, you can use FileZilla or some FTP tool to upload those files into your VM. Okay. How you are using two machines same time? Okay. So these two machines, I have 8 GB RAM in my machine. So these two machines, I have given 1 GB memory, right? So that is, enough to run Linux CentOS, minimum 1 GB memory. And then, sometimes it creates some problem, but it's okay. So if you are having, 4 GB memory, then you can reduce the memory to 512 or something, and see the systems coming up not. Or if you are having still serious concern about your resources, just configure name node and data node within one host. Okay, that's also fine. Can I query like SQL in Hadoop? No, but in Spark, Apache Spark, you will see we can write SQL queries over data loaded in the data frame. So we can load data into the data frame, and we can perform queries on top of that data frame. But we cannot even query in the Apache Spark RDD like SQL. But on top of dataset and data frame, yes, we can. We'll do that. Is there any change for the full setup manual which is uploaded in the website? No, it's all same. No change. Do we have to submit any assignment in this course? Yes, we'll share that assignment. Hello, Ibrahim. So I think all questions is over already.
Yes, question already answered. Now, if anyone asks any questions, I enable your microphone, then you can ask. Khan Muhammad Oliullah.
Hello.
Yes.
Okay.
Hello.
I was saying hello to him.
Okay. I enable their microphone, but no one can. Yes, Nazmullah Hassan.
Yes, sir.
Can you hear us?
Yes, sir. I heard you.
Okay. If have any question, please ask.
Sir, I have a question. The question is, my RAM is 4 GB.
Okay.
And I use one VM. How I am assigned 2 GB RAM?
No.
Sir, my question is, I am my RAM is 4 GB, main computer RAM. But if I assign 2 GB RAM to my VMware, the RAM will calculate 2 GB RAM or 4 GB.
So you see, if you see my screen now, so you see in my VMs I created a couple of days back, I assign only 1 GB per VM, and it's fine. So if you assign, 1 GB per VM, you can run 2 instance. So that will take 2 gigabytes out of 4 gigabyte, and you will, have 2 more gigabytes RAM for your operating system.
Yes, sir.
Yeah.
Thank you, sir. Thank you, sir. I got my answer. Thank you.
Okay, thank you so much. So anyone? Hello, Tanvir.
Yes, Mr. Gupta, I want to ask that in the PDF you have shown us to last class that you was trying that just try to create VM on using CentOS, right? So in my lab I have made it on
Okay.
CentOS, but I'm afraid you are using here one which is name node in it's a Windows machine and another is CentOS. So you are telling that there are some issues with CentOS. Is it suggested that should we use Windows client or we will go as you suggested to use CentOS client?
So, when you said, I don't get your question properly. So when you
Okay.
say Windows client, what does it mean? You are talking about Windows host. When you say client, it's confusing. Client just means.
No. I can see your screen, right? So,
Okay.
so it's a virtual box, and
Yes.
yeah, uh, the upper one. Yes. Which operation system in here?
I have, Windows.
FDR01.
Windows, yeah. Oh, this is both are CentOS, right?
Oh, okay. The icon, so I became confused for seeing the icon. Okay, thank you. Got the answer.
Okay.
Hello, sir.
Hello.
Yeah.
Hello. What will be the total mark distribution of this course? The final exam portion and the assignment part?
Yeah, Ibrahim, you can,
Yes.
I think, answer that one, right?
Yes, right.
Assalamualaikum, sir.
Total marks is 100. 20
Assalamualaikum.
for assignments and 30 for 50 for assignments and 50 for exams. It is 100
Assignments
marks.
means sorry, assignment means the exams we will give, right? Or the lab part and the exam.
Yes, yes. Assignments is different, and your exam, online exam, that contains 50 marks.
Okay. Online exam part contains 50 marks and the assignments contains
Assignment,
rest.
yes, 50 marks. Okay. Hello, Zakia.
Hello.
Assalamualaikum.
Yes.
Assalamualaikum. I'm Zakia.
Yes.
I have a question. How can I connect CentOS to internet in VirtualBox? I tried this, but I was failed.
Okay, sir.
So yeah, so I mean, how you are, I mean, browsing internet from your laptop? Can you please tell? I mean, how it's connected?
Yeah.
Is it connected using mobile modems or is it connected using your Wi-Fi router?
Wireless internet connection, but
So as I shown you, right? I mean, if you go to setting, just
yeah.
the VirtualBox, go to the network. So by default, you will be coming as a NAT connection, right? So if I start the VM, it will assign some internal private IPs. So there you would not have any internet. So just if you do the breeze adapter, right? Then this host will directly communicate with your Wi-Fi router. And if your Wi-Fi router is, I mean, giving the
I
IPs
did
from,
it, but it is not connected.
okay, but so you are using a Wi-Fi connection which is configured with DHCP. I mean, that might be one reason that uh, so I mean, how your, I mean, Windows PC is connected with the internet? You said
Yeah,
well,
my Windows PC is connected with broadband line, but this CentOS operating system was not.
okay. So it is directly connected with broadband, or it is the broadband is connected with your internal Wi-Fi router, and then your PC is connected. I mean, how? So are you connecting the direct broadband cable to PC? No, I think, right? You have a router
No,
inside.
Wi-Fi, with Wi-Fi. I have Wi-Fi.
Okay. So if your host is connect, I mean, in Breeze network and it is not assigned with IP, that means from your Wi-Fi router, you are not getting IP.
Oh, yeah. Okay, thank you.
Okay, Vishwajit. Hello, Vishwajit. Can you hear us? Rahul Gupta.
Hi, hello
Hello.
everyone. Yeah, I got your lab files that you have shared with the FileZilla that we're supposed to download with to our local PC. I was surprised. I'm using a Mac OS right now. So, is it possible you can share us the setup file in like DMG file as well?
So Mac OS, you can also, I mean, use some kind of VM virtual box so that you can install CentOS. But this virtual box, you just need to Google it and download for Mac.
Okay. The virtual box, I think file virtual vision, I think some kind of workstation that I have available in my laptop right now. Work vision for Mac.
So our intention is just to install the CentOS. So I mean, you can use any virtual box and just set up one or two CentOS so that you can, I mean, just follow the instruction and configure the HDFS.
By when will get the assignment for this class?
Before, I think, next class, you will get at least one assignment.
And so, how long the class is going to be for the next week?
No, we'd have more 4 classes in the roadmap.
Okay.
So within that, we'll be finishing all the assignment, hopefully.
So can I have one more question right now?
Yes, yes, of course, yeah.
So after completion of this big data, is it possible that you can arrange some classes for cyber securities as well?
Cyber securities. So I mean that I mean.
Yeah. I was not selected for that program for the masters that it was happening in Sri Lanka last year.
Okay. So I mean, Ibrahim, you can give that answer.
We have no any procedure to any class or more class for cybersecurity. We have already completed course about cybersecurity.
Okay.
So you can see our previous class videos. It's the DLE course 1 cybersecurity, and the instructor was Professor Kashunti Joysa from Sri Lanka. You can see our whole video in the DLE website.
Okay. Thank you.
Okay.
Thank you so much.
Thank you. So anyone?
Sir, Assalamualaikum.
Yes, Nazmul Suhan.
Sir, I have another question.
Yes.
Sir, can you show us your two configuration? I have seen two machine. I need two machine configuration fully, like RAM. I've seen you tell me that 1 GB RAM assigned, but I need to how full detail, please. Can you tell us or show us? You can send me as well.
Okay, you are talking about, I mean,
You two machines there.
Resource configuration of the VMs that you are going to create.
Yes, sir.
So, I mean, let me share my screen because it won't take much time. Just, I mean, if let's say I'm creating one new VM, right? So let's say click new, you give one, let's say host one. So I want to create Linux and let's say it's a 64-bit operating system. Next. So here you see you have a memory size, right? So now you can control. So by default it's 1024. Okay.
Okay, sir.
So if you go next, then it is asking for virtual disks. I mean, in which file this information will be stored in your Windows machine, right? So just go ahead, right, and go ahead with the virtual disks, and it's saying dynamically allocated. Yes. So now you can, I mean, give, let's say, if you have space, you give, let's say, 25, right? And you can select a preferred location. Either you can give D drive or C drive, whatever drive you would like to keep, and save, right? The BDI location will be there, and you just can give create, right?
Yes.
So when it is created, go to the setting, and then go to the storage, and you see this is a CD drive which is empty, and you have a I mean, CentOS I also already downloaded to you, right? So we sent one CentOS. So you select that one in your CD-ROM and place OK. Now when you start that VM, it will start getting loaded from that CD, and your window, I mean, CentOS installation is started, and you follow the steps to, I mean, install CentOS, and it's already in the documents that we have shared you. So just follow the step-by-step process. Okay.
Thank you, sir.
I know
Thank you,
it's,
sir.
I mean, if you are doing for first time, it's a bit challenging, but I recommend you, I mean, if you are facing any problem, just try to be familiar with Google. I mean, if there is something, so you select CentOS and move ahead, right?
Yes, sir.
Okay.
Thank you, sir. Thank you, sir.
Yeah, you're welcome.
Thank you. Assalamu alaikum.
Thanks. I am stopping for now. Yeah.
Hello, Mithun Kumar Ghosh.
Yes.
Yes.
Hello.
Please ask your question.
Hello, sir. How are you?
Hi. Hello. Yeah, I am fine. How are you?
Yeah, fine, sir. Sir, I have seen that the virtual machine I have created, it always takes a random IP. So it's a bit difficult for me to track all those IPs. So how can I set a static IP for the virtual machines?
Yeah, so
It's
I would
picking
like.
up every time a single random IP from my router.
Yeah. So what do you need to do? I mean, so your name is Mithun, if I'm not wrong, right? So you just need to log into your router with the management web portal, and
Yeah.
you go to the DHCP configuration, and you, let's say for this host, right? If you're seeing, go to the network and go to, if you select, you need to select the bridge
Yeah, I
adapter,
have selected Bridge Network.
and go to advanced, and if when it's not running, you can copy this MAC address, okay,
Yeah.
and get the MAC address, and in the DHCP manager put that MAC address and put a static IP in the DHCP pool,
Okay.
okay. So every time if you are getting from your DHCP router, for when you start this VM, you will get the same IP in each time.
Okay. Okay.
Okay.
Thank you, sir.
Yeah. You're welcome.
Hello, Abhimanyu Pandey.
Yes. Hello, sir. I have a really quick
Hi.
request.
Yeah.
Is it possible to add some code snippet in the Spark execution present? The last slide you had, I kind of got lost. I think up till RDD, I was understanding quite clearly. Uh,
Okay.
but the one before this. Yes, this one. Maybe next time, or you can just add like, I understood this part, but in the next slide, I didn't know what was happening.
This one or this
No,
one?
so I understood this. Yeah, how do these two code snippets apply to the next?
Yeah. So basically, this is just an example. So
Right.
today our intention is not to, I mean, go into the code level. So our intention is to give you familiarity about, I mean, how the RDTs and data frames, I mean, look like realistically, right? But conceptually, I mean, we need to understand what is RDD and what is data frame and dataset. That's what today's topic. So I mean, when we do the practical session, that time we will, I mean, work on RDD separately, and as well as on the data frame on, I mean, and at that time, I mean, the coding front. So I understand that, let's say, for example, here we are doing flat map group by. So this question or this type of, I mean, expression we'll be using explicitly in our practical session, and that will be more interactive. Yeah.
Okay. Thank you.
Welcome.
Hello, Mahmudur Rahman.
Yes, sir. Can you
Yes.
hear me?
Yes, yes, I'm here.
Yeah.
Okay, sir, I have a quick question
Yeah.
to Mr. Polas, sir.
Yes.
Yes, please.
Uh, Sir, actually, in Apache Hadoop,
Yeah.
in the download section, there is no 2.7.1 currently. Their minimum version is 2.10. So why have you chosen 2.7.1 for this lab? May I?
Oh, so you are saying, I mean, whenever you are going to download, there is no option to download this one, right? Hello?
Sorry, his microphone may be mute.
Yeah. Okay.
I just unmute his. Okay. Mr. Mahmoud Rahman,
Yes, sir.
can you ask the question again?
Oh, actually, my question was,
Mhm.
in the hadoop.apache.org
Yeah.
website,
Mhm.
they have minimum version 2.10 or 2.10, and their latest version is 3.2.1.
Right.
So why have you chosen 2.7.1? My
Yeah.
question exactly
Okay.
this
Yeah,
one.
yeah, understand. So it's not available in the, I mean, given download
In the
package,
repository, and yeah.
but there are links from where, I mean, we can
Yeah,
download.
I know. We can download
Yeah.
from the given link. But my question was, why you have chosen this one?
Because
Is there any specific reason for that?
yeah, there are specific reasons. Because the training materials, and I explained in the first class, if you remember, that the basic Hadoop ecosystem, if you want to download by yourself the Hadoop binaries as well as Spark or any other big data ecosystems component. So the compatibility between the components you need to take care, and that's why there are many providers like Databricks, I mean Mappers. So they are coming forward with some, I mean, consolidated package where they are maintaining all this, I mean, compatibility between different components of big data. So
Okay.
here, I mean, when we designed our course, not only for, I mean, these projects, I mean, I do training on many multiple, I mean, physical and online. So the overall training package has been, I mean, designed and compiled with some versions of Spark, Hadoop, and Python and Java, right? So that's why we are doing. So our main intention is to learn the basic things so that we start, I mean, knowing the knowledge and how to, I mean, used to it. So whenever you will do all these things, you, I mean, can easily download the latest version and do your jobs. So that would not be an issue.
Okay, sir, I understand. Thank you. Thank you for
Yeah.
your.
Welcome.
Uh, Thank you so much. So one participant at the last time he pressed the hand raise.
Yeah,
Just
please.
okay. We enable his microphone. Mr. Shibli Mullah.
Sir, assalamu alaikum.
Walaikum salam.
Actually, I was having a lot of issue with the CentOS about
Yeah.
installing it using the VM. Literally, first of all, the problem is with the one that that is provided through FileZilla. I mean, the installation file, the ISO file. So
Yeah.
that is not actually not working in my PC, and I emailed you, but unfortunately, maybe that was missed, and I haven't got any reply. So
Okay.
I tried to download the latest version of CentOS from the internet, and then I downloaded it. But the problem is still here. So when the installation is done, and when it told me to reboot it. So when I reboot it, it tried to install again. I don't know why does it happen.
Okay. So before, I mean, rebooting it, I mean, can you, I mean, disassociate your disks, I mean, from the storage?
Sorry, sir, I couldn't get you.
I mean, I'm saying that, so I believe you go to your storage, right? And
Yes. Mm-hmm.
and you add something right here.
Yeah, yeah, yeah.
So before rebooting, you can disassociate this one and make sure it's empty, and reboot again, and then it should go to, I mean, directly to the OS, because maybe, so in our case for this Oracle VM virtual, it's not happening. So whenever we're installing, it's not after rebooting, it is coming to OS. In your case, if it is going to DIX, you can, I mean, just make sure that your CD-ROM is empty, and then you press reboot.
Yeah, so I tried it actually, but the problem is like it asked me to go to the same location to find the ISO file. So it doesn't get it. So I don't know, somehow I managed to start it from
Okay.
other installation. But the thing is, I have to save it from there, but I can start it from the Oracle VM Virtual Box Manager itself. So is it okay just to use it from the previous session?
Yeah, I mean, if you're running the CentOS instance, that's all. I mean, we need, yeah.
So there is no dependency of of versions, right? So I can use any versions of CentOS.
The CentOS 7 related any patch version you can use, but I would still recommend to be in the CentOS. So in CentOS 7 also you will see different, I mean, patch versions are there. So that doesn't matter. I mean, as long as you are on CentOS 7, that's fine.
Okay, sir. Thank you.
Welcome.
So thank you, sir, and thank you, dear all participants. We can close our session today for now. Hope to see you in the next class.